Welcome to học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, a story or history of science in 100 experiments. Today we are going to read story number 100. Chúng ta sẽ đọc chuyện số 100. The composition of the universe. When Archimedes took his famous bath, the sun was thought to go around the earth, and the stars were thought to be points of light attached to a sphere not much further away than the sun. Now we know the composition of the sun and stars, and recent experiments have revealed that these are just minor constituents of a universe composed of exotic dark matter and dark energy. Along the way, the age of the universe, the time since Big Bang, has been pinned out as 13.8 billion years. Many observations have contributed to these discoveries, not least the studies of distant supernovae described on page 261. But the ultimate experiment so far was carried on board the satellite Planck, named after the man who first explained the nature of black body radiation. And the results were announced early in 2015. The satellite had been launched by the European Space Agency on board an Ariane 5 rocket on May 14, 2009. It spent years observing the sky before the first results were announced in March 2013. Observations still continued until October that year, when the satellite was switched off as it had run low on fuel. But the analysis of the data continued up until the beginning of 2015, when the definitive conclusions were announced. As its name suggests, the instruments on board Planck were designed to study in detail the cosmic microwave background radiation discovered half a century earlier by Alonzo Penzias and Robert Wilson. But where Penzias and Wilson could detect only a seemingly uniform hiss of radio noise coming from all directions in space, Planck could measure tiny differences in temperature of the sky from place to place, anisotropy, that revealed the state of the universe at the time the radiation decoupled from matter a few 100,000 years after the Big Bang. This happened when the universe was cool enough for positive nuclei and negative electrons to join together to make neutral atoms, at which point matter stopped interacting with electromagnetic radiation. Some of the photons detected by Planck came from the regions in which matter was more densely packed and became the seeds from which galaxies and stars developed. Others came from regions in the gaps between these seeds of galaxies. Crucially, this corresponds to temperature differences. The nature of these anisotropies, or ripples in the background radiation, depends on a balancing act in the early universe. Matter, a combination of dark matter and the stuff we are made of, baryons, tries to pull things together by gravity, but radiation in the form of an energetic photons tries to smooth things out. The interaction between these effects produces waves known as acoustic oscillations, with a mixture of wavelengths. When the radiation and matter decouple, the pattern of these waves is frozen in the form of the temperature differences from place to place, which Planck measured. The differences are tiny. In some places, the leftover radiation from the Big Bang is a few millionths of a degree warmer, and in others, a few millionths of a degree cooler. But Planck was able to measure the differences, and the experimenters were able to unravel the pattern of waves that produced them in a process similar to the way in which the individual notes that make up a guitar chord can be unraveled by analyzing the sound of the chord. The technique is called power spectrum analysis, and although it is a standard process, the complexity of the analysis was made clear by the researcher who described it as being like working out the structure of a grand piano by analyzing the noise it made when it was pushed down the flight of stairs. After all that effort, the result is that we know the composition of the universe in an astonishing detail. Just 4.9% of the universe is composed of baryonic matter, what we think of as ordinary matter, the things stars, planets, and people are made of. Another 26.8% of the universe is made up of dark matter, which is ordinary in the sense that it seems to be in the form of some kind of particles, but ones that do not interact with baryonic matter at all, except by gravity. And that leaves 68.3% of the content of the universe, more than 2/3, in the form of dark energy discovered by the supernovae teams. Along the way, Planck pinned down the age of the universe as 13.798 billion years, 13.8 billion years to one decimal place, and measured the speed with which it is expanding, the Hubble constant, as 42 miles or 67.8 kilometers per second per megaparsec. All of this agrees very well with measurements made by previous satellite known as WMAP, but WMAP's results were a little less precise, making the Planck experiment the benchmark for our understanding of the universe. Vocabulary now. Composition, constituents, contribute, satellite, anisotropies, dense, densely, crucial, crucially, oscillation, oscillate, oscillations, power spectrum, baryonic matter, pinned down, benchmark. Thank you so much for your time, and I will see you in Experiment 101. Bye for now.